Hi everybody, my name is Sebastian, and well, I'm just an enthusiast on Bitcoin. Some of you I already know. And so yeah, there is a hackathon that happened two weekends ago, organized by Blocktrade. It was a really nice initiative. We didn't go with a lot of expectations of what will happen. It was my first hackathon. But I came with some ideas, and then we met some very nice people. And together we decided, okay, let's try to put an idea together and work together. And then by the end of the day, four people who were working in a team, we came up with this project. And of course, it was not finalized by the end of the day, and it will not be in a short period of time, but it's just a proof of concept in a project. So basically, the idea is we built on top of previous ideas that exist on Bitcoin of making transactions with third parties and easier and especially faster, because one of the things of Bitcoin is that you have to wait for confirmations if you want to be sure that you're going to receive the money or the funds in your Bitcoin address. So the way that we structured this was basically we state a problem. A problem will be, in our example, a movie company that wants to sell you some movies, and you want to pay for it and receive the product immediately. So what happens is in the current solutions with Bitcoin payment, for example, if you pay for it, to be sure that the payment is in your possession, that the funds arrive to your address, to the merchant, you will have to wait around 10 minutes for a confirmation in the Bitcoin blockchain, which is the distributed ledger on Bitcoin that ensures that everybody agrees that this person, in this case this merchant, received the money and the funds. Other solutions that exist for years, like PayPal and credit cards, they give you also the sensation that the payment went immediately, but if you look at the system, actually you can revert the payment not just minutes or hours, but even weeks later. You can say revert that payment, and then in our example, the movie company will lose the money that they received. So we came up with an idea to, actually the name of the project is not even ours. We just came with the idea and somebody contributed the name to the project, which I'm very happy, so we didn't have to think about that one. And the idea is to use the existing Bitcoin payment protocols to pay directly or to pay a merchant from a customer, but making sure that the payment is secure and then you can accept that payment immediately without having to wait for a confirmation in the Bitcoin blockchain. The way we do this is we create an intermediary point, a third party, which is in this case a software called No-Risk Wallet. But the good thing is, in this case, you don't have to trust this intermediary third party, because what we do is we establish what we call in Bitcoin payment channels. We establish a payment channel between the customer and the service, in this case, No-Risk Wallet. And then the merchant also establishes a channel, a payment channel with No-Risk Wallet. So then you have these two associations that are separated. And at the moment that a customer wants to actually spend some funds on the merchant, in this case on buying a movie, the No-Risk Wallet will make sure that the money arrives directly to the merchant, but also with enough information and enough security for the merchant to be sure that it's impossible to revert that payment without the third party, in this case the intermediate No-Risk Wallet service, will put collateral in this case, so the money that the customer is paying as a proof that the payment is going to arrive to the customer, so or to the merchant in this case. So the customer is sure that he's sending the money to the merchant, and the merchant is sure that he's receiving the money no matter what happens. And then we have technical details, but basically the nicest thing that we came up with is this graph of how the money moves. Basically, these are our three actors. This is the merchant that wants to receive the money, this is the customer that wants to pay, and this is the third party, in our case, the Nordic wallet. And these are multi-signature address. This is an awesome thing that Bitcoin has, which is basically a Bitcoin address where the funds are controlled only by the owners of the keys. So the owners of the keys of this Bitcoin address, multi-signature address, are A and B. So funds can move from here to anywhere. Only this guy and that guy, so the customer and Nordic wallet agree on sending the funds somewhere. And in this other multi-signature address, it happens the same. Only with the agreement between the merchant and the third-party Nordic wallet service, you can move funds from this place to any other one. So what we do is a chain of transactions that makes sure that when the payment wants to be confirmed, the first one to agree is the merchant. The merchant wants to be paid. Then we agree on the payment as a service, and we agree on where we're going to transfer the money. And finally, who has the final decision to approve a payment, of course, is the customer, because the customer wants to pay something. So when all of them have signed the transactions in the correct order, then the transaction can be published, and everybody in this game knows, or in this transaction chain, knows that is sure that it cannot be reversed. That's basically the idea. Then I was very happy that at the end of the day we have some mock-ups of how the UI could look like, and the team was very motivated. I never worked with so motivated people in my life. I really enjoyed it. I'm very happy we won by surprise the award of the hackathon, and then we put it on Reddit last week. We got a lot of feedback from the community, a lot of encouragement, and some points of improvement of this concept. There are several things that we know is not perfect because it's a proof of concept. So there are some issues in Bitcoin like transaction malleability, if I can pronounce it correctly.
Yeah, because they didn't understand what is the problem with
basically, this is a chain of transactions. Maybe you follow it, maybe you don't follow it, but you see there are arrows, so the money gets from here and then goes here, 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 so they are linked. To link them, there is something in Bitcoin called the transaction ID, and you can generate that, and it always, in general, is the same, so that assures that it's the same. But there is some bug in Bitcoin that if a malicious actor, in this case a malicious miner, wants to change that ID, it could still change the ID and make the transaction valid, which will break. For this guy, for example, he will think that the transaction is not valid.
So it has to do with it's the same kind of attack on blockchain info a year ago. That if you put a malicious miner can predict your tax ID or not?
No, you can change your AEX ID,
yeah,
but you cannot change the stuff that's in there. So it only changes the ID. So your system thinks that the transaction isn't in there, but it is.
But it isn't like a double spending attack. It's not that it looks like double spending. No.
But specifically in the case of micro payment channels, this is a problem because a micro payment channel has two transactions that are linked together. Mm-hmm. So if the first one gets changed transaction ID, then the second one becomes invalid.
But I mean, why should the malicious miner do that?
I don't know.
I mean, can he steal your money, or he can
only change the TX ID, but what's in the message you can still say only the ID change. But there are workarounds, technical workarounds provided by blockchain info and some others who could evaporate this risk. I think it is.
Are the statistics on how many transactions are not acknowledged or confirmed by the community? Because I spoke with someone and I noticed this problem. I said, hey, it's not 1 on 1. So I see the issue. But said, that practically doesn't execute. So I'm curious, is it really a problem?
I don't know personally, I read some comments of people saying there are some specific nodes on the network that consistently do this every now and then. So for what reason, I don't know. How often it happens, I'm not sure.
Okay,
And what is your statistic?
That is this attack what you're discussing. I don't understand it, but that's okay. And the effect is that the transaction is not confirmed.
The effect, it will vary. It will probably look like the transaction is not valid for some people. So depending on who you are looking at in the network, it will not be valid to you. So it is also the implications are not very severe. So the money will not go away from anybody. Nobody can steal the money in this case. What will happen is at the end, C will not be too sure if he received the money or if C received the money, but A is not sure if he's the one that paid. So it's history.
A has lost. Okay, A, C. That's the end situation.
Yeah.
I pay. I have to wait. I asked this also. I didn't get an answer. Maybe from you. I have to wait 10 minutes or so to get the confirmation. It lights up and it's confirmed on my in my wallet. What happens if it doesn't light up? Did I lose the money to the other guy, or does it go back in my wallet?
No,
The sender.
no, you cannot change it with these attacks problems. You cannot change where the money comes from or where it goes to. So at the end, it behaves like we expect. Or the money goes to the merchant, or it goes back to you.
It's not a fixed case that it will return or will go to the merchant. It can be both ways.
With a single transaction, it always goes through.
So
In this complex situation, it's a little bit difficult.
But in a
single
normal transaction,
it's always it will go.
it goes. So
Yeah.
what's the problem if it anyway will go?
That's,
Your
that's
system
why
automatically detects the identifier is needed here at B to identify the first transaction. But what malleability does is you change that ID of the transaction. So the transaction is still happening, but the system wouldn't recognize it.
Yeah, but we forget about B. We make it simple, one transaction
yeah,
from
in
me
that-
to the
in that
merchant.
case, it
It's
doesn't
just a
affect.
single transaction.
In that case, the merchant cannot recognize that it comes from me.
But still,
It
doesn't-
doesn't recognize it comes
Yeah.
from you, but it just has another transaction ID.
So it recognizes that it comes from you.
But if he has his system software built
if it's
on recognizing the transaction ID, he'll say, hey, something's wrong.
Exactly.
That's
And
what
then
I
he goes on and he says, okay, but I got the money from the guy, it's his problem.
Yeah.
Yeah,
So,
the point
I'm
is
not-
that the system works by recognizing the ID. And because you can chain...
You create trouble.
Yeah.
that's
So
what
you
I
can
do.
create a little bit of trouble, but not a lot, because you still know who sent the money.
Yeah, and you can make your software that if you don't recognize the transaction ID, it will go looking
Yeah.
For
And
who
for the
is
address.
And
So
is-
have we a problem? Do we have a problem?
And is this also a problem because it, as far as I understood, it doesn't happen on the chain yet?
Yet.
Yeah, so because you want fast
Yeah.
payments, so in the end some kind of
goes
transaction ends up in the blockchain, but that is the result of this transaction. But in other words, if you would do this on blockchain, it would be another story. Separate.
No, you can do it on the blockchain because you have the first confirmation already there. So it's already started.
Yeah.
They actually do it by recognizing the DXD and immediately firing another one.
Yeah.
Another DXD which has the same content as the first one. Then you can have a scenario that goes valid. The system could recognize it. But what is said is true. You can build some software to detect this get rid of. And you will also only see transaction validity cases if there is a financial incentive.
Yeah.
So with blockchain info, they have a load of money, and then it became interesting.
Yeah.
Start testing what's wrong with the system.
But yeah.
Because you now create 3 transactions,
Yeah.
which enhances the chance that there's something going wrong in one of the 3. The result could be that if the attack is made, then what is then the effect? They will say, okay, it was not okay, you get a warning.
Yes, I guess in the worst case, what will happen is that you will have to wait 10 minutes until the transaction is confirmed, and then you know who paid who.
Yeah. Okay.
Because when it's confirmed, then the blockchain is the source of truth, and you can see the link of transaction, where the money comes from, where it goes to, and then, yeah, can change it. But until it gets confirmed, some people can do these nasty attacks to kind of spam the network into believing this is not real. Although that's the only thing that can do with it. Saying, yeah, this is not real, this is not good.
Because with the normal payment systems, you said you can always get refunds, but that's because people say, I want my money back.
Yes.
And that is not, that's not one of the features of
No.
Bitcoin. So that's quite another problems related with it.
And
Okay,
in this case too, in this case, if after 5 minutes you want your money back, you cannot revert this.
Yeah.
C will get the money.
Yeah. Okay. Anyway, see what
Yeah.
I have another question. If you want to pay to a merchant, you and the merchant have to be connected to the same middleman.
Yes.
Right?
Yes.
So if there are multiple people who offer the service as a middleman, you will usually choose to connect to the biggest one.
Yeah.
Right?
Probably.
Probably. Yeah. That will be. It will get most new customers. There's a strong network effect.
There will be an
Yeah.
incentive to centralize.
Exactly.
Yeah.
Those were going on for a P2P network. All those middlemen connect to each other. And you can make multiple calls.
transaction.
Yeah, the good thing is that the middleman here, it doesn't matter who is. It can be a hacker. It doesn't matter. Because the hacker has to put a collateral, so...
Yeah, so maybe he cannot steal money from transactions, but he can choose who can connect to him, and he can put arbitrary conditions on that. For instance, you have to give your ID in order to connect to him, and you have to give your transaction information, what your transaction is about, and he can block certain people, he can block certain types of transactions.
Yeah, that's totally possible as that will be his business proposal, no? I propose I will give to you 0 confirmation transactions faster if you give me your ID and blah blah blah. It's a deal if you accept it, okay?
And if you don't accept it, you don't have access to all those merchants and all those customers.
Then I guess like in competition, no? Another person can do the same thing but say, yeah, less.
Could you compare it somehow with how dark market works? Because dark market also has a kind of a system that you would need some kind of trusted party to make a transaction between people selling goods on dark market.
I don't know the details of that market, but you say trusted third party. In this case, it's a non-trusted third party.
Yeah, okay, but trusted in the sense there would be an incentive for organizations, for entities to act as a middleman solution. But I mean, it isn't trusted in the sense that I have to know. But they function as a broker kind of system.
With a lot of these markets, I know there are escrow services that you have to select somebody to do escrow system and decide this person paid or this person didn't deliver the goods, blah blah blah. But at the end you have to trust the person that is making the judgment.
Yeah.
In this case it doesn't matter if he is a machine, a human or whoever, because they have to put a collateral.
Yeah.
So what's the business model?
Good question. We don't have any. That's the answer.
Winning hack prices.
You
Actually,
cannot live on that, I think.
there is another thing I forgot to mention. There is another drawback that in a normal transaction where you have to wait 10 minutes, you will pay once the fee of Bitcoin. And in this case, you will have to pay exactly 4.
4 times.
Yeah, 4 times.
Oh yeah.
So the first one is to establish this channel, the second one is to establish this channel, and the third one and the fourth one. Well, maybe you can say that B will put some of the fees itself, I don't know, depending on the business model they have.
But every channel is used only once for a single transaction.
In this basic model, yes. If you want to use it for micro payment transactions, I guess it could be possible, but then probably for future payments, when you want to resettle things, you will have to involve all the people that is in here plus the new people that you want to pay. So, yeah.
But will it blockchain then, with all kind of small transactions?
With what he's saying, or what I'm imagining in my head is, let's say we make this transaction and it's not yet confirmed in the blockchain, but C has an insurance, which is the collateral from B, that he will get paid, okay? And then we know that after a few minutes, he will get paid. Maybe we can say that instead of a few minutes, make it 3 months. And in those 3 months, we can readjust all of this if everybody puts their signature and agrees on it. So you can expand the window of time until this gets confirmed and keep resigning all the transactions that you want and reassigning all the money that you want as long as everybody agrees in the proper order. And that will have no bloat on the Bitcoin blockchain. Because
so in other words, if you keep the channel alive longer, in the end, only the channel...
the final settlement.
Yeah.
Yeah, and in a sense, it's like a Ponzi scheme. I mean, like, you pay the merchant with the people who are doing the next transaction, right? I'm seeing it.
Sorry?
You're paying like, the final merchant with the payments of the guys who come after the initial one, right? Because you said
No.
Then maybe if I may say it like this, we are here, we don't know each other, we are in a dark room, and I want to pay Sebastian. And then I start asking, do you know a route to Sebastian, if I'm right? And Janus happens to know, and Janus knows another one who has a route, and in the end he knows Sebastian. And then we agree that we are going to pay, so I pay Janus 10 Bitcoin, Janus pays Michel 10 Bitcoin, Michel pays Sebastian 10 Bitcoin. Am I saying it right?
Yeah, you put more intermediary points, so you make it more complex than this.
Oh, okay. Yeah, I'm saying it the Huwala way, or the Ripple way.
Yeah.
But that is how it works. So so I don't have to travel to him to pay him 10 Bitcoin, because I put it to him, he puts it to him, puts it to him. But the point is, if you decide that if you trust each other and you decide that. And you know that Janus also wants to pay Job through me. Then that way, in the end, you close accounts. It's just like banks do. But banks don't do it automatically.
But I'll explain a little bit more about the collateral. Because I'm the middleman, so I have to put collateral where?